So yesterday we factored linear expressions with algebra tiles, and today we're going to do it with just our algebra skills and not all the pictures. So we're going to use the properties of mathematics to factor linear expressions. First, I'd like you to open your book to page 775, and you will see the same questions that I have up here. And with your partner, I'd like you to begin trying to do this problem. So pause the video, try to do it. Maybe you won't finish it, but try to do it. So now that you've kind of tried to work through this, let's work through it together. A rectangular yard is being separated into 4 equal sections for different items at a yard sale. How do you find the area of a rectangle? Okay, so that's length times width equals the area. The area of the yard is 40x plus 120 square feet, meaning they don't know all of the measurements yet, but they do know it's 40 times x plus 120 square feet. So what's the area of each section? So I know that my length and my width is what we're trying to, equals the area, which is 40x plus 120. And I know I have 4 sections, so I'm kind of going to set up my paper like we did the algebra tiles, except for I'm going to have 4 sections. And all together in these 4 sections has to be 40x plus 120. So then what's the area of each section? So go ahead and pause the video and take a couple answers from students if they have an idea. If you got, I took 40x and 120 and I kind of separated them out into each part. I know I needed each of them to be even, so 40x, I could put 10 x's in each space, and, or plus, I could put, 120 into each section. That would be, so I'm dividing that by 4, would be 30, so, and I can put 30 in each section. Okay? So the area of each section would be 10x plus 30. So if x is equal to 25 feet, what's the total area of the yard? So that's just your basic substitution. 40 times 25, because I'm replacing x, plus 120. 40 times 25, I'm going to think my mental math distributive property here. 40 times 20 is 800, and 40 times 5 is 200. So 800 and 200 is 1,000. Plus 120 is 1,120. What was it? Square feet. So I'm just going to use feet squared. Okay. So the reason we're doing this is because it's kind of hard. This one was nice and easy to split up, and this is kind of like our factoring we did yesterday. But would you want to factor this with algebra tiles if I asked you to actually find the length and the width of this rectangle? I mean, think about putting 40 X tiles out in 120 little tiny yellow things. It would take a long time. So we're going to use our math skills and operations and our knowledge of the distributive property to factor these kinds of expressions in a little more efficient way. Okay, so before we get to the methods, let's talk about the vocabulary. So why don't you pause the video and write all this down, and then I will go through and we're going to fill in some examples in this orange box. So a monomial is a number, a variable, or product of number and one or more variables. So that's a really fancy way. When I show you, it'll be really easy. But first I want to point out mono means one. So a monomial is one term. Like we talked about when we were combining like terms, this is just one of the terms. If there's a plus sign, then it's not a monomial because we have 2 terms. So some examples could be like a monomial is a number, so a monomial could be 3. It's a variable, it could be just x by itself, Or it's a product of numbers and one or more variables, meaning it's a multiplication problem, like 4y or 3mx or anything like. So that's right there. That's 5 different monomials. Things that are not monomials are things with more than one term. So like 3 plus x, that's not a monomial. That's 2 terms. Or 3mx plus 4y, not a monomial. Okay, so we're going to work on factoring out monomials out of some non-monomial things. That's what we're going to do. So to factor, we're using it as a noun, would be numbers multiplied together. So, like, I know if I asked you to factor 12, or what are the factors of 12? Sorry, what are factors of 12? You'd say to me, like, maybe 3 times 2 times 2. Those are the factors. Okay? To factor a verb is to write the product of the factors. So I kind of did that. I guess I can list the factors is what I maybe should have done up here. 3, 2, and 4. There we go. And then if I was actually factoring using the verb, it's writing the product of the factors. So these are factors of 12, and I'm missing a few, I just realized. 1 and 12 and 6. I think that's it. Alright, now I got it this time. So what are the factors of 12? Well, here's a whole bunch of different factors of 12. To factor as a verb is to find out the parts of 12. So it's like doing that, breaking down into that tree. So 6 times 2, and then 6 breaks down to 3 and 2. So I factored 12 because 12 equals 2 times 2 times 3. And that's actually prime factors of 12. I could also say that 12 equals 6 times 2. That's factoring 12 as well. So there's lots of different ways to factor 12. All right, so and remember back when we were simplifying fractions, we found the GCF of numbers, and now we're just going to find the GCF of monomials, which is exactly the same, only with some common letters involved as well. So for example, if I wanted to find the GCF of 4x and 12, I have to think kind of 2 things. What do the numbers have in common? So what is the GCF of 4 and 12? And then I'm also saying what variables do they have in common? Okay, so the variables is pretty easy. You can see they both have an x. That's in common. So that'll be part of our answer. And then you have to find the GCF of 4 and 12. So if you need to do it with the factor trees, make sure and check your fraction foldable to do that. But I think most of you know that the highest factor between 4 and 12 is 4. So the GCF of 4x and 12x is 4x because they have a 4 in common. There's a 4 in 4x, and I know that 12 breaks up into 3 times 4x. So they have a 4 in common and an x in common. So therefore their greatest common factor is 4x. Okay, same thing over here, 18a and 20ab. Now if I didn't know what 18 and 20 had in common, I remember I can always do my tree. 18 is 9 and 2, and then 9 is 3 and 3. And 20 is 5 and 4. 5 is prime. 4 is 2 and 2. So then I can make my list. So it's really 18a equals, let's see, 2 times 3 times 3. 2 times 3 times 3 times a. Don't forget your a. And then 20, ab, really factors into 2 times 2 times 5. 2 times 2 times 5 times a times b. And find out what they have in common. So they have in common, let's see, a 2 and an a. Okay. So what is their greatest common factor? What do they both have in common? They have a 2 times an A in common. And don't make the mistake of saying 4A. We're not multiplying them together, all of them. We're trying to see that these things equal 2A and these things equal 2A. So what do they have in common? 2A. Alright, so I'm just going to write my answer. The GCF of 18A and 20AB is 2A. Okay, so you try the next two. Pause the video, try those two, and check with the teacher. Now we're going to use our knowledge of GCF to factor algebraic expressions. And to factor an algebraic expression, that means you have to completely remove the GCF. Okay, so how we're going to do that is to reverse distributive property. So right now, this is kind of the answer to a distributive property. So what I'm looking for is something, you know, in the form of distributive property. This could be a plus, this could be a minus in here. So something times a group is going to be my answer format. Okay, so what is 3x plus 9 going to break up into? So in your head, the process is to think about or find the GCF of 3x and 9. And you can do that in your head, or you can do that with showing some work, either way. So this one, I think we all know the GCF between 3x and 9 is a 3. I can pull a 3 out, and I can pull a 9 out. So remember, it's kind of like dividing in your head, because to distribute is multiplying. So I'm kind of undoing by dividing out. So I'm going to take a 3 out of 3x. So 3x divided by, so I'm going to actually write this up here, 3x plus 9. So what I'm doing in my head is kind of thinking, okay, divide them both by 3 and put it back on the outside where it was to begin with. So I have my 3 on the outside, and what I have left is x plus 9 divided by 3 is 3. Okay, so this is my final answer, and I can always check myself by doing the distributive property. So you can always check by saying, okay, 3x plus 3. Will that work back up to my answer? 3x times 3 times x is 3x, and 3 times 3 is 9. Okay, good, it worked. So they are the same. So we've created equivalent expressions here. Okay, let's factor 12x plus 7. Well, okay, what do they have in common? I'm not sure. So 12x breaks up into 3 and 4 breaks up into 2 and 2. 7 breaks up into, well, 7 and 1, and that's it. So 12x equals 2 times 2 times 3 times x. 7 equals 7 times 1. There's nothing in common. So instead of writing, what we would write then is this cannot be factored because there's no GCF. And then write your because. How do you know? Not just because I think so. It's because there is no GCF. Okay, so on the next slide, you're going to try. There are 3 problems for you to try. So pause the video and try. And once you're finished, raise your hand, have the teacher check, and then we still have one more example. So. Okay, now a real-world example using factoring, which is kind of like the first one where we're talking about like a garden or an area. Since we're talking about multiplying, it's always easiest to think about area because it's multiplying. So the garden below has a total area of 15x plus 18 square feet. Find the possible dimensions of a garden. So let's remember what the word dimensions means. Dimensions is like the length on the width or the height or any combination of those things, whatever way you are. There's 3 dimensions, length, width, and height. So since this is a rectangle, we're just looking for length and width. Okay, so what is the, or I guess in this one maybe you could say height and width or whatever two you want because they're interchangeable, but we're just looking for two of the three dimensions. So we want to find the possible dimensions. So that means how can I break up my 15x and 18? And that's just factoring. What times what will give me 15x plus 18? So just like before, what times what will give me 15x plus 18? Okay? And it says possible, meaning there could be more than one answer. So how can I break up 15x and 18? Well, some of you will see it right away, and you can go ahead and write down your thoughts. If you're not sure, break up your numbers so that you don't make any mistakes. 15 is 3 times 5, and those are both prime. 18 is 6 times 3. 3 is prime, 6 is 2 and 3. Okay, so 15 equals, and that's actually 15x, so 3 times 5 times x. And 18 is really 2 times 3 times 3. You get that? Yep. Okay, so what do they have in common? Well, they have a 3 and, oh, I erased it instead of highlighted it. Oops. Okay, all right, let's highlight this time, shall we? We have a 3 in common, and that's really it. We have one 3 in common. There's another one, but 15x doesn't have another one to go with. So I can factor out a 3, so I'm going to do that. 3 is going to be on the outside, and on the inside, what do I have left over? Well, 15 divided by 3 is 5x, plus 18 divided by 3 is 6. So that's what I have left over, and you can see there's your length and your width right there. So the possible dimensions of the garden are 3 by 5x plus 6. Notice how I wrote that differently? Because when we speak about things in their dimensions, we use the word by, which is also a word for multiply. Okay? So when we're actually talking, instead of saying 3 times the quantity 5x plus 6, which is kind of a little mathy, we kind of switch over to our regular language and we say 3 by 5x plus 6. Okay? All right. And now you can move on to your homework, and absolutely you all need to try the challenge problems.